Elbow covers are always applied so that the overlaps shed water. If the elbow is at the top of the pipe riser, the elbow is installed after the jacketing. If the elbow is at the bottom of the pipe riser, the elbow is applied before the jacketing. You'll need to first determine which side of the elbow the longitudinal overlap should be placed in order to hide the overlap. Place one elbow half cover on the insulation to check the fit. Then place the second half on the elbow. Don't forget your tie wire to secure the cover snugly against the insulation. If you crimp the cover when applying the tie wire, your fit is too tight. Use a sheet metal punch or drill to create screw holes in the heel overlap seam of the cover. The number of screws you'll use is dependent upon the size of the cover. The larger the cover, the more screws are needed. Place the screws in the holes and tighten them. Then create holes in the throat seam and apply your screws to the throat of the elbow cover. Remove your tie wire. If you are applying the elbow cover to a low temperature pipe, you want to use strapping and seals instead of screws or rivets. The same sequence is followed, except that you don't need to create holes in the throat or the heel. If the specification allows, apply caulking or a sealant to the overlaps to protect against weather. There, you've just applied a two-piece elbow fitting cover. Application of gore-type elbow covers differs from that of two-piece. But again, your overlaps must always shed water. You'll need to check insulation to make sure no ridges or bumps exist, since gores must be applied over even, uniform surfaces. Place the first segment crimp edge on the lowest part of the elbow, paying close attention to the overlap. The first segment should overlap the straight pipe jacketing. The widest part of the gore segment should be aligned with the seam on the middle of the heel. After the first section is in place, you need to secure it with tie wire. Repeat this process for each succeeding segment, being sure the bead covers the crimp on the previous section until the complete elbow is covered and straight pipe section overlapped. You will probably need to realign the segments. Next, you need to secure the gore elbow with screws, or strapping if the pipe is low temperature. Screw holes should be drilled at the circumferential overlap of each segment, and the screws are then applied. Remove the tie wire from each segment and dispose of it properly. This completed the sequence for applying both two-piece and gore-type elbow fitting covers. We have not dealt with field fabrication of gore-type fitting covers since most insulation shops use the pre-manufactured fitting covers. Fabricating a small fitting cover is not too difficult. Fabricating a gore-type cover in the field, however, is much more difficult. Field fabrication is literally an art form which requires much more training than we can accomplish today. The next fitting you'll encounter most often is the T, which occurs when one pipeline intersects with another. The pipe that intersects is called the branch. The pipe that continues without interruption is called the main pipe. If the branch line of the T is above the main pipe, then the main pipe should be jacketed before jacketing the branch pipe. If the branch line of the T is below the main pipe of the T, then the branch line should be jacketed before the main line. If the T is in a horizontal position, feel free to first jacket either the main or the branch line, whichever is easier. First, we'll learn how to apply the jacketing to the main pipe at the T. Then we'll apply jacketing to the branch pipe. Place a section of jacketing loosely around the insulation at the T and line up with the longitudinal overlap seam with the previous overlap. Then measure from the center of the pipe T to the edge of the previous section of applied jacketing. Add 2 inches for the overlap. Remove the loose jacketing section and place it on a cutting surface, moisture barrier side up, with the longitudinal overlap edge facing you. Next, you'll need to recreate the measurements already taken on the jacketing section to determine the center point of the T-pipe. Then measure the diameter of the insulated T. Set a pair of dividers at 1/2 the diameter. Place a divider point in the center point and mark a circle. Use your circular cut sheet metal shears to cut out the circle, and then use the straight cut sheet metal shears to cut from the mark from the longitudinal overlap edge to the T cutout. Place the cut section of jacketing around the T. Remove and retrim the jacketing if necessary for a correct fit. Remember to use the tie wire to secure the jacketing section. If the longitudinal overlap edge cut extends beyond the 2-inch overlap, cut a 2-inch by desired length insert and place it under the cut. If the specifications allow, secure the insert underneath the jacketing with screws. If additional T's of the same size are required, this section can be used as a template. Next, apply your strapping and seals. Remove the tie wire. If the T branch is located on the lower side of the main pipe and the T section is complete, seal the main line jacketing to the branch line jacketing overlap with specified caulking or sealants. Let's take a look at jacketing the T branch at a pipe T. Again, if the branch pipe is located on top of the main pipe, the main jacketing section is applied first. If the branch pipe is located under the main pipe, then the branch jacketing section is applied first. Place the jacketing section on the branch line at the T and secure it loosely with tie wire, making sure that the longitudinal overlap matches the previous overlap. Then measure the distance from the end of the jacketing to the longest point of the branch line T. Set a pair of dividers at this measurement and follow the contour of the main line T. Then mark the branch line section. Remove the jacket section from the insulation and place it on a cutting surface, moisture barrier side up. Use a circular cut sheet metal shear to cut along the mark. Place the jacketing section back on the insulation and check for a proper fit. Mark and retrim your jacketing section if necessary. When the fitting is correct, hold the jacketing in place with tie wire and apply your strapping and seals. Then remove your tie wire. If other T's of the same size are to be jacketed, this piece may serve as a template or pattern. The next most frequently encountered fitting is the flange valve cover. Applying jacketing to the insulated flange valves is similar to the process of applying jacketing to T's. The valve body is similar to the main section of the T. The valve bonnet is similar to the branch section of the T. The end of the valve body and the valve bonnet may be covered with jacketing or may be covered with coatings and reinforcement membranes. Prefabricated valve covers from the jacketing manufacturers greatly simplify the application process, or the flange valve cover can be field fabricated. The best technique to permanently secure the valve ends and the valve bonnet to the body is to use Pittsburgh seams, which require special machinery normally found in sheet metal shops. The special machinery creates a fold with an edge, commonly referred to as a Pittsburgh seam. A lip is turned on the edge of the end piece with a sheet metal edger. The lip is inserted into the fold of the seam on the body, and the edge is folded over to create a permanent seam. The first thing we're going to do is to cut the ends of the valve cover and the bonnet. Use your dividers to mark the outer diameter of the valve body and add 3/16 inch. This allows the lip to be turned on the outer edge. Mark the inside diameter, OD of the pipe insulation, and add 3/16 inch. This will allow the lip to be turned out to overlap the pipe jacketing. Cut the inner and outer circles using your circular cut sheet metal shears. The resulting piece is often called a donut. Mark and cut the end of the bonnet in a similar manner, modifying the inner cut to fit the valve stem. Next, we need to cut the valve body cover. Select a piece of jacketing that will fit around the valve body with 2 inches of overlap. Measure the width of the valve and add 1 inch to allow 1/2 inch on each end of the piece for the Pittsburgh seam. Then measure and cut the bonnet using the same techniques as if you were measuring and cutting a T. Run the edges through a Pittsburgh seam machine to obtain your Pittsburgh seam. It may then be necessary to run the jacket through a sheet metal roller to get the curvature required, since the Pittsburgh seam machine adds rigidity to the jacketing. Your next step is to apply the body section in a manner similar to how you applied the main section of a T. After the body section is applied, then you're ready to install the 2 ends and bonnet. Place the donut piece on end and insert the lip into the seam. Check for proper fit and fold the edge over the lip. Use a wooden mallet to close the seam. Then cut and apply the bonnet jacket in a manner similar to how you applied the branch section of a T, but be sure to allow for the Pittsburgh seam. Then install the bonnet in a manner similar to how you applied the donut. Seal the jacketing to the valve stem and seal all seams in the donuts and valve bonnet with specified caulking or sealants. If a Pittsburgh seam machine is not available, another method of fabricating a valve cover can be used. You'll need a sheet metal beater to create interlocking beads at the ends of the valve bonnet, and end covers. Measurement and cutting of specific pieces is the same, except that the dimensions would be smaller since less overlap is needed to make bead edges instead of Pittsburgh seams. Valve fitting covers are more complicated than the other types of fittings, and you'll need to practice this one. Following these steps, however, will help you to create a first-class fabrication.
Let's take a break for a few minutes and review what we've learned today. What do you need to remember for each and every job you'll encounter? Most importantly, before you jump right into installing the jacketing, you need to think about what you want to accomplish. What's the best method to hide all overlap seams and fastening devices? Where do you need to start the jacketing? Do you have the proper tools to accomplish your task? Do you have the proper jacketing materials cut to the right size? Are you working safely? Quality workmanship will always make sure that a 2-inch overlap exists on all longitudinal and circumferential seams, and each overlap will be designed to shed water. Quality workmanship will always have longitudinal overlap seams aligned with the fastening devices aligned in the overlap seam. Quality workmanship will always provide a weather-sealed, weather-tight jacketing system. Quality workmanship always keeps the underlying insulation dry. Quality workmanship always is concerned with the final appearance and the elimination of dents, scratches, and abrasions. Quality workmanship will never abrade the moisture barrier on the jacketing. Quality workmanship is planned before it's done in order to be as efficient as possible. Throughout the course of this videotape, we've given you background information about the installation of protective metal jacketing over insulation. We've both struggled with the fundamentals and a few fine points concerning the installation of metal jacketing through horizontal and vertical piping and various fitting covers. And we've been surprised to learn that it's not as hard as it looks. All it takes is some practice with the material. Certainly, no one expects you to get right out there and do it perfectly the first time. But in this short videotape, you've learned what often takes several weeks to learn on the job. Please feel free to go back to the previous section if you're unclear about anything. Review the tape as many times as necessary. Work with the products more.
This video instruction has been